Ooh, looking handsome.
Yeah?
Yeah.
So you have a piece of equipment, machinery, a device of sorts that's made of multiple metal parts. One of those parts breaks. What do? You call the manufacturer. Manufacturer either doesn't have a replacement part or it's exorbitantly expensive, and you don't have a choice. You gotta pay it. Except if you're me or any metal fabricator with usually some sort of CNC machine or lots of time on your hands, you can make a replacement part. So in this video, I'm gonna show you how to make a replacement part for, in this case, a milk dispenser. Yummy. But before that,
ladies and gentlemen, this video is sponsored by ShopSabre. Why? Because I reached out to them. ShopSabre is a very easy company to advocate for because they make a hell of a product and multiple products that honestly have fabricators in mind. They have some of the best customer service. Everything's American made. The machines are incredibly versatile, modifiable, you can change them around, and they're incredibly durable. Even the entry-level stuff is built like a tank. So consider ShopSabre for your next CNC need.
wow, thanks Past Me. Now off to another Past Me.
Hello viewers, welcome back to Lift Arc Builds. My name is This Old Tony. No, I'm just kidding. Today, I've got an interesting video, hopefully. It's gonna be part research and repair. It's gonna be part how to make parts for the plasma cutter, how to cut parts in the plasma cutter, and probably a little bit of machining later, if I had to guess. But what this is a the valve to a milk dispenser used, in this case, at a local coffee shop. A friend of mine, Carissa Joy, brought this by. Sweet Donkey Coffee. I'm actually wearing their hat right now, which makes me laugh. I love this hat. So what's wrong is there was this piece that broke. I don't know if you can see this. There's a, this piece should be one piece, and pretty clearly it is not. This was essentially the valve for the milk, which is kind of surprising that a metal on metal valve was enough to keep the milk from not coming out. The word milk grosses me out more and more as I say it.
Dude, I was just thinking.
But anyway, so that would sit in there, and then this handle locks into that notch there, and I imagine it would sit like this. This weight is huge, but I think it's supposed to keep the valve closed. And then when you want to dispense the milk, this rocks forward, and then when you're done, you push it back. So there's a pin that rides on. So anyway, our task today is to remake this piece. And what I'm gonna attempt to do is cut it out of 1/8 inch stainless. This looks like it was some sort of pot metal. You can see the crystalline structure in there. It kind of looks like sand a little bit. That is either a cast part or a sintered part made from powdered metal. In any case, it's cheap to make. It makes the parts super cheap, but they're very brittle. Hard, but very brittle. So making this out of 304 stainless is gonna obviously be a huge upgrade, but I'm gonna try to do it rather quickly. So the first thing to do is I'm gonna trace this and then carefully measure with my calipers and a ruler as to dimension it, and then I'll transfer those dimensions into a 3D model. So I'm gonna just trace. I'm just getting the basic shape laid out so that then I can measure everything. So it looks like 1.8625. All right, so rectangle, we're gonna go 1.8625 there, and then let's measure the width. We have exactly 1 inch, which is nice. They thought about that. Okay, so here's our rectangle. And now we gotta put our square in 0.6875. Off this back piece, it is 0.6875 here. And we're gonna dimension it from this back wall, 0.6. And then I'll do a center point rectangle. I'm drawing in Fusion 360 if that wasn't already obvious. Now we gotta draw this funky little slot. So there's a few ways to measure a slot, and then Fusion there's a few ways to draw a slot. Really just need the overall width and length of the slot. So it's 0.575 wide, 0.5, it's 0.5 long. What am I doing? Create a slot, overall slot, and I'll have it right on this center line as well, 0.175. There we go. Oh, let's see, I gotta radius these corners. So let's do a fillet here and here. 1, nope, 0.5, because the whole thing is 1. And then a fillet here and here, 0.5 as well. All right, I believe this is our piece. It looks right. It's a good thing to do anyway. I gotta measure the thickness. 0.125, that's fantastic. So I'll make an extrusion here, 0.125, and now it's a 3D part. And now we can go drawing from design, full assembly, pick our paper size, 1:1 scale, and we'll print this out and see how we did. It looks right. That is rad. There we go, a 1:1 drawing. So I do that process a lot. There's a lot of times people bring in parts that are broken or just like, hey, this part works, I need 5 more. So recreating identical parts is all about careful measurement, understanding of scale, and really being able to read a set of calipers, because these guys are great. So you start by going new, and I don't know what my plate's gonna be, but it doesn't matter. I'm just gonna do 12 by 12 by 8 inch. And so here's the plate. This red box is supposed to simulate the raw material that you throw on the cutter. So now I'm gonna go back to Fusion, and on the left side under sketches, here's sketch 1 that was responsible for creating this extrusion. So I'm gonna right click on this sketch and hit save as DXF. Walker, if you could blur some of the sensitivities in this file, system, like the IP address of my server.
Sure, yeah, that sounds like it.
Yeah. Milk valve plate. Best part name ever. So save your DXF somewhere that you can find it, and then go back into EnRoute, and once you're here, literally just right click in empty space and hit import. Navigate to your file again. Milk valve plate open. All right. And so here we are. It actually exported the construction lines as part of the DXF, so I'm just gonna delete those. Don't need that. And then when you got these pink lines, they are just individual line segments. It is not a piece of closed geometry. So you need to go up here to transform, merge selection, and hit OK. And then it should look like this. The blue lines are exterior cuts and the red lines are interior cuts. Now we have to toolpath. And so what I did was scan and copy this page from the owner's manual of my Hypertherm, the actual plasma cutter, not the table. And so they give a table with estimated kerf width compensation. So I go down to stainless steel, I look at which 45, 65, or 85 amp setting would provide the best quality, which quality you usually want to pick the one that the thickness of metal falls in the middle of its cutting range, if that makes any sense. So for stainless steel, 45 amp consumables land 10 gauge material right in the middle of its capabilities. So my kerf offset is 0.067. So you highlight your geometry, go up here to kerf compensation. I've already programmed 0.067 in here. If you want to know how to add a new tool, there's all kinds of informations out there, or drop me a comment, I can show you how to do that. I have a pretty standard entry and exit that seems to work, so I do a line entry and exit at 60 degrees and the same distance as the thickness of the material. And then you do that, and you can see now what we've got. So the green lines indicate entry and exit. The blue line indicates the cutting path, and then you can see it is offset from the geometry to compensate from the kerf of the cutter. Hence, kerf width compensation. So I can also change the entry and exit points. Like, I'm probably not gonna have it enter and exit on the middle of that radius. I'm gonna have it be somewhere on a flat, and same here. For no other reason than because there's sometimes a little bit of a burr where the entry and exit happens, and if that's on a flat edge, it's much easier to grind off than if it's on a radial edge. I'm gonna have to sand and grind and file this part anyway, but make it easy for myself. So I'm gonna exit that tool, and now we are ready to cut. Now I gotta go turn on the shop. I just got here in the morning, so let's go do that. So load your material. One sort of trick we've used to get it square is to put two similarly shaped pieces on the table like that. Now I know it's exactly 4 inches off the rail. So the piece has been squared. I'm going to turn on the, see it, open the ShopSabre Plasma, and first thing you gotta do is hit home, and it'll run through its homing procedure. So it'll find all the limit switches, and so it does Z-axis first, and then it'll do Y-axis. Now, one thing we can do while this is happening. Now that that computer's on, we can export this file. So I just select all the geometry, I go to machining, output, selected to file, and I have these computers linked over the network. So there's a folder on the desktop of that computer that is a network folder that I can access here. So I already have my stainless folder pulled up. Milk, valve, part, plate, there you go. I was like, this was a three banger, like milk valve plate. So I'll hit save, and now it's exporting the .tap file over there. Perfect timing, because now our machine is homed. So the next thing, I just put fresh consumables in here yesterday, so I know I'm good. So we gotta find our 0 point. This plate has a little chamfer to it, so I'm gonna make, oh wait, I forgot to do something. Oh boy, this is good to know. So everything that I know of in CNC Plasma is indexed on the bottom left corner. So if you look, if I hit go, this is a 12 by 12 box. It would have cut the plate, the piece there, and that's not helpful. So I'm gonna grab this and move it down to the corner so that it's close to the origin. So when I zero the machine, I'm telling it where this corner is. And so everything off of the bottom left corner is where the geometry will be cut. So that's close enough. I don't want to waste all that material. I have a nice big square of stainless, which is quite expensive at the filming of this video, and if I punch a hole right in the middle of it, that's pretty useless. So I will hit save, and I'm gonna re-export this. Replace, yes. All right, where they sheared it, there's a little like bevel here. So I am going to zero it ahead of that bevel. Right about there. So now I go over here, I click XY0, and now this computer knows where the bottom left of the plate is that the part is to be cut out. So I go in here to config, and I will select 10 gauge stainless. I've already messed with my settings here, so I'll hit done. So we got 10 gauge stainless loaded in here. Now we need to load the file, so I'll just hit Control O, which is the Windows shortcut for open. Grab milk valve plate, open, and we're ready to cut. So let's send it. So, stainless is a tricky metal to cut. There's some dross. Stainless has a tendency to like sugar, people call it, which is the dross is in like sort of crystalline structure. I knew I was gonna have to do some post-processing anyway, so now we're gonna go back to the sanders and grinders, clean this up a little bit, and then test fit it. So I'm just starting with a file because, you know, this plate has a purpose and a tolerance, and I don't want to remove too much material, and the material I do remove, I want to make sure it is in line. This is a pretty far cry from a surface grinder for you machinists out there, but this is a good place to start. It's getting really hot. Getting there. If I had like a tumble polisher, I would use that, but I'm gonna hit it with some Scotch-Brite. All right, there is our new part. It's pretty satisfying.
Yeah.
Let's go see if it'll dispense milk. All signs point to this working. Yeah, that hole's open fully. Still getting a little gummed up. Ooh, very nice. You can look at a good view if you can somehow look in there. So I think functionally we've replicated the original part. So now I gotta figure out this shitty bolt. I can insert it all the way and keep spinning. I might just tack weld this in place. That is not stainless steel. It's some sort of zinc. I bet it's cast zinc. What I'm gonna do is just try to weld directly on that fastener. Yeah, that's some pretty toxic shit that just came off of it.
Yeah, that doesn't smell very good at all.
Basically just made a little burr on the end of the bolt that is hopefully gonna jam it in there. I definitely can't remove it. It won't spin anymore. So in the future, the solution's gonna have to be more mechanical than that. But we'll give this to her and see if it works. I wish it was better looking than that, but I'm sure people say that about me too. Oh no. That is supposed to be its closed position. You see the gap at the bottom of that hole? Mm-hmm. That's the hole that's supposed to allow milk through. That's supposed to be closed, but when you let it fall, about an 1/8 inch gap opens up at the bottom of the hole. I don't have time to make another one right now.
Makes me wonder though, is that truly the part that's solely responsible for holding out the milk?
Yeah.
Because like,
It's hard to believe that it would be.
because otherwise, it's not sealed. Even the previous one.
No.
I wonder if there's a plastic tube that goes in it and it pinches.
That's exactly what it does.
So that might be perfect.
That's exactly what it does. That's why this is so f***ing heavy.
Because it has to.
Pinches off a tube. Oh, you're brilliant. I guarantee you that's how that works.
Yeah.
You're brilliant. You're brilliant. You're brilliant. So it's like a guillotine
Yeah.
for the tube.
Yeah. So then that works just fine.
That makes total sense.
Because there's no f***ing way that that's the only thing that holds.
No, there's no way. Well, there's only one way to find out.
Yeah.
All right, ready?
Test 1. Look at it work. Come to Sweet Donkey, everybody.
Woo!
Hey, thanks for watching. Sure does feel nice to fix stuff instead of throw it away and buy a new one. It's a cut point. Guys, don't forget that I'm still in the running for the DIY Hero competition. I've made it past 2 cuts, and there are 2 more cuts to go until voting gets reset. So I could use all the help that you could give me, and it really doesn't just help me. All proceeds go to benefit the American Lung Association. But I am in the running to win $25,000 and a 2-page feature in Make magazine, which would make a small fish like me real happy. So give if you can. There's free votes every day. Link in the description. Thank you. Love you. Bye. Subscribe. Like, comment.
What are we doing next?
F*** off.
All right.
Next is more things you'll enjoy.
All right.
That's all you get.
Okay. And that's going in the video.